Hello and welcome back in the Sheet Metal Workshop, and in this video I'm going to show you how to measure a band and make a segment band made out of sheet metal. Okay, now I have here in front of me a pipe rack. It's a pipe rack for practicing, and I've got it from the Installation Learning School from Hamm in Germany, so thank you to the crew who gave me the availability for using this and loaning this pipe rack. And well, the thing is, what I want to do is I'm going to measure here this band. So I need to know some information. So like I need to know the pipe thickness, I need to know the radius, and I need to know the insulation thickness. So let's get started. Okay, now first I want to know the outside diameter of the naked pipe. And we have here 60 millimeter. That means 60 millimeter is the pipe diameter. And now I want to measure the radius. So you can measure the radius. First, it's important to see if it is a 90-degree bend. So you can check it also by holding two folders, fold ruler, and then here put this here both together, and you can see here in this corner it's a 90-degree. Now some pipes and bands have here a seam, a weld seam, and then it's easy because then you hold your ruler on the weld seam and the other side, and then you push those two rulers together until a point comes. For example, this is the center pipe here, and here's the center pipe, so I hold it and looking for when they come together here. Okay, so when this is 90 degrees, so in the center pipe I have here 200, and if I hold this here, from here until the center pipe I have also 200. That means this band has got a radius of 200 millimeter. So 200, here's my 200, so if I hold it like this, see, that's my radius of 200. Maybe. Okay, so the next thing what we know is, or what we need to know is the insulation thickness. So it's all different on each chemical plant, or in some building there are different insulation specifications. So I'm just gonna show here the most standard way how it's mostly been done. So there are different types of insulation, and I'm gonna use mineral wool, and I have here a piece, so I'm gonna put in, it's a little piece, but anyway I'm gonna put on here my mask. And so I have here now a piece of insulation, and it's got an inside diameter of 60 and an outside diameter of 160 millimeters. So if I put it here, so that means that's now how my insulation is going to be to cover the pipe. And this here is 50 millimeter. So that means I have of my metal an outside diameter. I have an outside diameter of 160 millimeter. So I'm going to put up my mask. It was only a small piece, but anyway, safety first. Okay. And here also another example with a smaller radius. So I'm just looking here for this 90 degree, see, and then you can see here it's a little bit straight, so I have to go down. So I will say 140 millimeters I have here radius, from here where it ends and here middle pipe, 140. So this is another example. But I have also a pipe list here where all the standard dimensions, dn in inches outside diameter, and then you find the radius, and that is by the most standard pipes, where you can also see the weld seam. Good. Okay, well, that's it what I wanted to show. Okay, so now I showed on two types, smaller band and a bigger band, how to measure a radius. Now the next thing what also is possible, so I'm going to make a sketch. Now there are different ways to bring it on paper, and I have here now a tablet with me, and with this tablet there's a software on it from Swatmans, from the cutting machine, and if I want, for example, to measure it digitally, I go here on the drawing for isometrics, and here you can see this is my pipe, and okay, now I'm standing in front of it, so I'm going to measure it now. And normally we start with the metal, the screw length. So I have to measure the screw, how long it is. So okay, the screw length is 70 millimeter. That means from the flame until the center of the pipe we have 700 millimeters minus 70 millimeter makes 630 millimeters. So I'm gonna click on the green arrow number 8, and now it comes, my pipe comes, so I can also move this. So, and it's got a length of 630. Okay, that's my pipe. So now the band comes, and oh, I forgot something. I'm gonna go here. I have forgot something. So I have here a pipe of 100, so 160 was the diameter with insulation, but I'm going a little bit more air space in between, so that sometimes I give 5 millimeters, sometimes 10 millimeter, depends, but so I'm going to make it 10 millimeter bigger in diameter. So instead of 160 diameter, I'm going to use 170 millimeter diameter. Then we have here the radius. So the radius we measured 200. Okay, and how much segments we want. So we're going to make a 5-part. That means I want to have 4 segments in the middle, and I want to start a segment and an end segment. So that makes 5-part. Okay, now everything is set up. Swage allowance we have here 4 millimeter. Okay, that is okay. So now we go back to the isometric, and now we start again. Okay, this is now my starting piece, and we said it's got a length of 630. Okay, now the band comes. You see, that is my band. So it sets automatically, it gives me a size of 440. So if I measure here from the center, 440 is here where my thumb is. Okay, that will do. So I will keep it 440. Okay, but because I have a T-pipe coming in, I need the seam here on the inside of the pipe. So that means I can here move the seam. Oh, not too far. Okay, so the seam is down, and so normally I want to have here, because probably as a box is coming, so the starting piece must have a flat swage, and under that flat swage a small piece of 5 centimeter comes. So when a box is coming under it, it will be covered, because we are pretending this is an outside job. So I have to give here on this and you got here for the flank. Now you can here see it. I'm going to make it a little bit bigger here. See, now the flank is here on, and I want to go another 5 centimeters shorter, 50 millimeters. So instead of 630, I'm going to give 570. Okay, well, that's my pipe. I can also show it in isometrically form. You can print it out. But okay, that is only one possibility I wanted to show. It's also digitally possible, and we're going to do it first by classic, by hand, and therefore we're going to need a piece of paper and a pen. Okay, now we're going to start with the sketch. So we're going to end up with a female swage, so that's the X, female swage. And we said we want to hear the flat swage. Width down with an end plate on it. $50. Okay, now we want to have the seam here under, so that's the seam under. And because we have here this flat swage, I'm gonna make this one out of 2 parts. It's easier also for the fitters when there's a flat swage somewhere to make it 2 parts. Okay, well, that's now my pipeline. Now the information was, the pipe was 60 with 50 millimeter insulation, and we said we're going to give 1 centimeter, so 10 millimeters. We give a little bit more space, and we make a diameter of 170. Now we measured the radius is 200, and we want to make it a 5-part band, so 5-part. Okay, now we've measured this length, and we measured 570 was this length, from there till there. And then we have also this length here, we said 440. Okay, and then later on, normally here comes then box, and because you already know, you can also draw the cutout with it. And down on there also. So okay, but we are gonna concentrate on the band. So the information we got, and as next what we're going to do is we're going to make the template. So I'm gonna put here a working line of 20 millimeter. Okay, now what we do now is we have a radius of 200. So what we already can do is from the 0 point here this is here my 0 point, and from there we go with the radius 200. So that's my radius. And in the first segment video I showed the way how we do it in school, and now I'm going to show a method, a different method. For example, if you have this method does not work with a 2-segment bend. So 2-segment bend doesn't work. 2-segment doesn't work. So 3 segments, if you have 3 segments, is equal to 300 millimeter. If you have 4 segments, is equal to 400 millimeter. And now it goes, I have 5 segments is 500 millimeter, 6 segments is 600 millimeter. So it doesn't work with 2 segments. Okay, now I have a band. It's a 5-part. So 5-part segment is 500 millimeter. And that is meant 500 millimeter here from the 0 point. From here, you go 500. So here's the 500 on the line. And now I'm going to mark here. So, okay. So this distance from here until the 0 point is 500. What I do next, I'm going to pull up here this line 90 degree. And now there's a formula, and it's a constant formula, so it's always 79.5 millimeter, this length. I mean, it's a 99%, but if you use always this size, you're always good. So what I'm going to do next, 7.9, that's almost 8. So here's my line. 7.9 and a half. That's it. So what I do next, I'm gonna draw the angle from that 0 point here through this point. And now what I can do is I'm gonna draw my circle here, the diameter. So diameter 170, the half 85. So I'm just gonna mark there. So this is now my circle. Okay. So now I'm gonna pull up the middle line. And now I'm gonna divide the circle. And next what I'm going to do is now I'm gonna pull up these lines up. Okay, so now I have pulled up all the lines, and so this is here my 0 line. I'm just gonna mark it to see it better. And we're going to give, so this is 20 millimeter, so we're going to give 5 millimeter swage allowance. You can also do it with 4, it all depends on what wheels you use. So I'm going to give 5, and what I'm doing next is I'm going to number it. So this one is the smallest, so these are now my points, this here. See, so these now are my points. This is with the swage allowance, so number 1, 2, 3, 4, 5, 6, and 7. Now, 170 multiplied by 3.14 gives us 534, plus 30 millimeter overlap is 564. So I here already have a metal what is cut 564, and I already prepared and made a template. I already made so I have here my circumference, and I have on both sides 50 millimeter overlap, and between that is the real circumference that is divided in 12 equal parts. So now we're going to take over the numbers. So it's first we want to know, normally we want to make the band where the seam is like it looks like a fish at the end, so I want to have the seam where number 4 is. That's the side, from the side view, so the number band goes like this and the seam must be on the front. So number 4 is then the outside number here, and also the outside number here, and the one in the middle, 1, 2, 3, 4, 5, 6, 7. So this is number 4. Now you just go now, second one, you go number 3, 2, 1, and then again 2, 3, 4 is already there, 5, 6, 7, and it back again, 6, 5, and 4. Good. Now we're going to continue something. What we do is now we're going to drag over these numbers to finish the template. Okay, now we finish all the points. So next step, what we are doing is we're going to connect it. But we can also do a check, because we know the band is 90 degrees and we have 5 parts. So I'm divided it in 5 parts. That makes each segment is 80 degrees. So one side of the segment is 9 degrees. Yeah? So one side on a segment is 9 degrees and the other side, that makes 18. So what I can do is, I have here now scale it on 90 degrees, and now I'm going to move it 9 degrees. So here on 81, so that means this angle is 9 degrees. See, we can check it, see. And what you also can do is, normally it should, the first 2 points, see it also. So these are always, so I know I'm good. Just to check, you can do it with every band. Just divide the degrees in the parts how you have, and then like just I showed it. Okay, so now we go to the other side. Now, the three in the middle are always in one straight line. 3, 4, 5. Okay, now the rest is to make here this curve. Therefore we have this one. Okay, well, that's it. And next thing what we're going to do is I'm going to cut it out by hand. Okay, let's see. Okay, that looks good. Okay, well, that's my template. So next thing what I'm going to do is I'm going to mark the holes. Okay, so my template is done. And the next what I'm going to do is I'm going to write it down. Diameter 170, radius 200, and it's a 5 part. Okay, so template done. Okay, now we're going to continue. So first what we're going to draw is the starting segment. It's 570 long. We will give 50 millimeter for the flat. That means 585 millimeter. But the radius is 200, so 585 minus 200 makes 385. So 385, I'm going to take size from the starting of the metal. I go 385 and put then this segment on it. So because it's made out of 2 parts, that means 170 diameter multiplied by 3.14 is the circumference 534 divided in 2 is 267 plus 30 millimeter overlap is 297. So I have already cut here, prepared metal, a half metal of 297, and what I'm going to do is I'm going to make here first a working line. I mean not the working line, I'm going to give the overlap from 50 millimeter. So 50 millimeter each side, just like on the segments. Okay, so that means 30 millimeter is the overlap. So now I'm going to line this up. Okay, so, and now we go 385. from here, 385. And here also 385. And now I'm gonna put on my template on it. See, it must fit exactly. And now I'm just gonna draw the holes, pull here the line. Same thing I can do down here under, just to mark the holes. Okay, so that's my starter segment. And we're going to cut it out. Okay, so now this is my starter segment. So I'm gonna get here a side swage. Here comes a female swage, and here down we set 15 millimeter. And we're gonna round it in this way. It's a half, and this one is also a half. So that's marked. That's the way when I work in production, I do it like this. And now the next step comes, and therefore I need a bigger metal. So this is now also here the circumference. And what we do next is 440 is the end segment, minus 200 radius makes 240. So we go 240 from here, from the start of the metal. And here also 240. And now and I am also going to scratch on each side 15 millimeter overlap. And what we do now, because the seam is now under, that means in the throat, and this is here the 0 point, so I'm gonna make a hole in it, see? And now I can look through it, so I'm gonna put here this point here, and here also on the line. And so now I have here my end segment, and what we're going to do next is we're gonna draw all other segments now here. So I need 4 of them. So what I'm going to do, I'm just gonna find a size so I don't have too much rubbish. So for example here 350, so I'm gonna put here 350. And now I'm gonna mark this segment, copy it another 4 times, complete with all the holes and everything. Okay, so now I draw everything on the metal, the copy, and next thing what I'm going to do is I'm gonna cut out those holes and cut out the segments. Okay, now everything has been cut out. So these are the segments. So the band is going up, so then it becomes here a side swage, here female swage, male swage. So that's everything the same. Okay, this one becomes also a male switch here, female here, and it's coming like here. Okay, so it gets here the side switch. Okay, now that's for it for now, the band. So what we're going to do next is we're going to switch everything, round it, and putting some screws in it, and then put the band together. Okay, now we're here on the switch machine. I have here the 0 number in it, and from plate until center of the roll we have 5mm. That's the 5mm switch allowance we have. So now I'm gonna just put here in a side switch. Okay, now next thing, rounding. Okay, so now we're done. What we do is we start with the starting segment, and I'm gonna make here another hole. Normally I drill everything off, but okay, this will do. So what we're going to do, we're gonna first switch the band and then putting in here the flat switch. Okay, so let's go to the machine. Okay, so the female switch comes first. So now this is straight, horizon, exactly, see, first time. And by the second time you push it a little bit down. Okay, that's the female switch. And now we do here the same. And now the male switch. Also, so here now let's go also straight. First time, second time you pull it up. I usually go with the male switch a little bit more than the female switch, so let's see how this is going to fit first. Just a check. See here, half hole. Okay, it's closed. So what we do now, we're gonna switch everything like we did with these parts, and then we go try to put it together. Okay, well, that was the last one. And what we're going to do next before we're putting the band together is I'm gonna change those wheels very quick in flat wheels, and then we're gonna stretch it. Okay, flat switches are in, and now next okay, well, the screw is too much. Okay, I should have thought of it. It was too much on the side, but no problem. We're going to continue. Okay, that will do. So that is for the rain. So I already have prepared a piece. So I made this diameter 5 millimeters smaller, so 165, and this one is going here in, but normally we put here a back switch on 50 millimeters, so I'm gonna change those wheels very quick again back. No. Okay, switch is back in, and we're going to make here 50 millimeter back switch. Okay. And now it looks like this. So next thing what we're going to do is we're gonna build this here in. So this one goes in, see, like this, and then here the box comes down here on it with the cutout, and no water can get in. So that's the starting piece. So next what we're going to do now, we're going to put on the rest of the segments. Okay, well, there it is. I mean, let's have a look. Okay, well, 90 degree. Okay, so that's the bend. Let's check the sizes. So we should have 570 from middle bend till the switch here is 570. Okay, and then plus these 50. Okay, 440. So this is here. The screw is 440. Here's with my thumb. So 440. That is also correct. Okay, so this is the end result. It's going to be fitted like this. Okay, that's the way it should be. Okay, maybe I'm going to do a video about it, how I'm going to fit it. So for now, segment bend part 2. I hope you enjoyed the video and see you in the next video. Thank you.